So here we're going to talk about arc length. Now, what is arc length? Now, first of all, I know that you see central angle at the top of the page. All that means is that the angle is going to start from the exact middle of the circle, but that's all it actually means. So anytime you see that there's a central angle, that means that whatever angle that you're measuring is starting at the middle of the circle. But arc length is the thing that's really important. It's related to that central angle, but it is a little bit different. Angles show how much something has turned, whereas the arc length actually shows how much distance was traveled. Well, how is that going to be different? I want to draw a couple other circles here. All right, so here we have something that looks like a gigantic bullseye. But what I want to point out is that there is a central angle. As we can see, we have one line at the starting edge, and then we have our terminal side right over here. Let's say this central angle is going to be, 135 degrees. Or if we convert that, it'll equal 3 pi over 4. So this central angle is going to equal 3 pi over 4 radians. Now I want you to think for a moment that on this little orange circle, if you were an ant and you had to walk all the way over here, you wouldn't have to walk that far. But if you're on this green circle and you had to walk, you would be walking a lot farther. But does that make sense? It's the exact same angle. However, since the circle is larger, the arc length or the amount that you would have to walk is longer. And then even then, on this red circle right here, if you were an ant and you had to walk, you would be walking a whole lot farther than the ant on this central orange circle. So essentially, that's going to be the difference between arc length and the central angle. For each one of these circles, orange, green, red, and black, it all has the exact same central angle, which is 3 pi over 4. However, the arc length is different. Now, with that in mind, how do we actually calculate this arc length that we speak of? And here's the cool part. You actually already know how to calculate arc length, and you've done this before. And you might say, that is impossible. Well, let me ask you, how do you calculate the perimeter of a circle? You might say that's easy. You would say that's 2 pi r, or 2 pi times the radius. And now you know where that 2 pi comes in. Because to calculate the arc length, all you have to do is take the radius and multiply it times whatever the angle is. So for a full circle, that angle is going to be 2 pi. So 2 pi r, 2 pi times the radius. And that would be the entire circumference, the arc length of the entire circle. But if you only want a section of the circle, you use whatever angle that is given to you. So let's try that in this example. Monster truck tires have a radius of 33 inches. So we have the r. How far does a monster truck travel in feet after just 3/4 of a tire rotation? So this one is a little bit tricky, but let's think about this for a second. What actually is happening? I want you to imagine as a tire is rotating, the only distance that a vehicle can travel is when the tire is actually touching the ground. So every time the tire moves, the car moves as well. And it can only go as far as the arc length that it has turned. So all this question is asking is, what is the arc length? So all this question is asking is, what is the arc length of 3/4 of this tire? So let's draw this out. And I would implore you to actually draw some of these things out. Now let's think about this. If we have a central angle and we're doing 3/4 of a tire, that means it's going to be broken up into fours, and then you're going to use 3 of them. So this is going to be our central angle right here. Now, what is that going to measure? Well, you may see here now it is necessary for us to know exactly how many radians this is. We cannot use degrees Because remember, like I said before, degrees are not actually related back to the circle. So if you use degrees here, any of the numbers that you get are not actually going to make sense. So what we're going to have to do is we're going to have to find out how many radians is this. Now, we do remember that this is going to be 270-degree turn. We know that because of the circle that we made up here oh so long ago. And we can see that if we have this angle, it's going to be 270 degrees. So I believe what this question wants us to do is that we want to convert this into a radian first. That way we can actually use it in our formula. So if this is going to be 270 degrees, we're going to plug it into our formula. 270 degrees over 1 times pi over 180. And that's going to equal 3 pi over 2. Now, if that was difficult for you to do, please give these more practice because we will be doing a lot of conversions as we move on. So 3 pi over 2 is the central angle. So what would be the arc length? Well, if we remember our formula, all it is just going to be the arc length times the radius. And we know what our radius is. But I'm going to write this down. S equals theta r. Now, there's a couple things. I know that S doesn't sound like arc length, but we usually use S in these cases. Just deal with it. It will be fine. Just remember that it means the arc length. Another thing is that you see r theta, but I like theta r. Why is that? Because of 2 pi r, the thing that I talked about earlier. It's in a more comforting format when you say theta r. So here we have 3 pi over 2 being our theta. So S will equal 3 pi over 2 times our arc length, which is 33 inches. So we're going to type this into our calculator and we're going to find out what our arc length is. 3 pi over 2 times 33. In our calculator, if you notice, if you press the divide button, it gives you a fraction straight away. That will be very handy. So we're going to say 3, but where is our pi button? Well, if we hit this keyboard here, we will see that there is a pi button right there. We will say pi. 3 pi over 4 times 33. We have 77.75. So our arc length is going to equal 77.75 inches. Notice I use inches there, which is the same measurement as we used before.
All right, guys. So I made a mistake. I hope that you guys caught my mistake, but actually, Mr. Fish caught my mistake and days later finally decided to text me about it. So my mistake was that on the calculator, I divided by 3 pi over 4 and not 3 pi over 2. So that's going to make this 155.5 instead of what we have here. Do 155.5. Okay, so as you can tell, I am not infallible. As much as you think that I am perfect, I am not.
Now let's try our guided practice. This is the point in the video that I would like you to pause and see if you can do this on your own. This one in particular is very important to do on your own because it is a little bit involved and there might be something that you're a little bit caught up on. So please pause the video. Now I know that you paused the video, so let us continue. A circle has a diameter of 9 centimeters. Find the arc length if the central angle is 60 degrees. Round to the nearest tenth. So let's give this a shot. We're going to draw a circle and the central angle is going to be 60 degrees. We know a straight up and down line is going to give us 90 degrees, so 60 is going to be somewhere less than that. So we'll say there-ish. We'll mark that as 60 degrees. Now to get our arc length, we need radians. We cannot use degrees. Again, it will not make sense if we use degrees. So let's take our 60 and we're going to convert that into radians. We'll take 60 times pi over 180, which will equal pi over 3. Again, if you struggle on that, please put a little bit more effort and time into doing these types of problems. It's not bad if you can't do it, it just means that you need a little bit more practice. So now we're going to use our formula. Our formula is the arc length is going to equal theta times our radius. Well, we know both of those things. So our arc length will equal pi over 3, which is our central angle, times our radius, which is 9 centimeters. So let's go into our Desmos and we're going to find out what is pi over 3 times 9. It is going to be 9.42. Now, remember, it said round to the nearest tenth, so we're going to round to 9.4. So our arc length is going to equal 9.4 centimeters.
Okay, so I wish that was the only mistake up there, but apparently I made another mistake that Fish also had to point out, which is that they give us the diameter of this circle and we want the radius. So if we're going to use the radius, it would be 4.5 instead of 9, because as we all know, the diameter is twice the radius. Ah. So instead of having times 9 over here is times 4.5 because obvious reasons. So pi over 3 times 4.5 equals 4.7, not whatever I had before. So that would be 4.7. And that is the actual answer. Ugh.